So you guys will have to be really tuned in. This is 8.6. This is factoring what are called ax squared plus bx plus c. So the one difference, do you see it here? It's got a triple underline here. The one difference is that a will be something bigger than 1. Okay, in our last lesson, a was always 1. And so you're using the big X by multiplying the 1 times the c. Now this time, the steps are exactly the same as the big X on these. As a matter of fact, here, one thing that's different is, see, this is not 1. So the number that goes up here is not 2. This is what you need to be aware of. It's not the last number on here. A lot of students think that because the last lesson it always was. But the number that goes up here on the top is 3 times 2, or 6. So do we see how the 6 got there? That's really important. 3 times 2. So we're still going to start with the big X, and they've got to add to equal 5. I think you guys could probably just tell me what they are. Without listing all of them out, right? And then we go to step 4 here. It says fill in the box. Here's the box. This is a really cool connection. It connects multiplication by the box or the table with factoring and the big X. That draws them together. So what we're doing, this is in like a college textbook. This would be called splitting the middle term or factoring by grouping. So what we are doing is taking this 5x and splitting it into 3x and 2x, and now I have 1, 2, 3, 4 terms that I'm going to write in the box. And it says where to write them. It says put the first term in the upper left. The first term is 3x squared, so write that in the upper left hand side of the box. Then it says last term in the bottom right. So last term is the positive 2, goes in the bottom right. Both factors finish with 1 variable each. Here's what we mean by that. You're going to place the 3x here and the 2x here, and it doesn't matter if you switch these up. It makes no difference. Okay, the order of the middle terms doesn't matter. So is it clear on how to fill in the box once you get these 2 side numbers? Brogan, you with me here? So how did I get the 6? One more time here. Did you see how? 3 times the 2. The front number and the back number give me the 6. Then you get these, just like you did before. 3 and 2 multiplied equals 6, add equal 5. And then we rewrite this trinomial as 4 terms in the box. The first term goes here. The 3x squared goes in the top left. The last term, the 2, goes in the bottom right. And then these 2 numbers here and here, we tack on an x or whatever the variable is and put it here and here. Okay? And then the final step is you pull out the GCF. This is why we learned GCF factoring first. From both columns and both rows to get the factored answer. So I told you that it's really like taking this number 12, right, and figuring out what goes here and here. That's what we're doing. Okay, we're figuring out what goes, actually we're going to figure out what goes here and here. That's where we're going to place them in here. But we're finding the dimensions of a rectangle with this particular area. The area is what's written in the rectangle. And we're going to find out what goes on the outside, which are the dimensions. And those are the factors. So what's the GCF of this first row? Greatest common factor of the first row. In terms of numbers, it's got to be 3, right? And then we've got to take the lowest power that you see on the x's here. So 3x goes out here, which is what I would expect. Remember, we're working backwards from the multiplying stuff, right? Jacob? We're working backwards from the multiplying. So we've got 3x out here, and then we should have just a number out here. It should be a binomial with something times x plus or minus a number. What's the number that goes out here? What's the GCF of the second row? So in other words, what's the greatest common factor between 2x and 2? No? We pull out a 2. And then the greatest common factor of this first column, in in terms of the numbers, is just a 1, but see that there's an x in each box here? So we're going to pull out an x here. And then if there is nothing that you see in common, you don't put 0 here, 1 will always go into both numbers. So 1 goes right here. So here's what we're saying. This quadratic trinomial, 3x squared plus 5x plus 2, let's erase all this stuff and bring it back to its original state, is equal to x plus 1 times 3x plus 2. If I were to multiply these, I would get right back to the original problem. Let's just check. 3x times x is 3x squared. Oh, that's the first term. 3x times 1 is 3x, right? X times 2 is 2x. If I add the 3x and 2x, that gives me the 5x. And then 2 times 1 here is 2. And so this represents both the factors and the original quadratic trinomial. It's all in that box. So the edges are the factors. The middle is the actual trinomial. So that's one of the methods. We've called it the X box. I don't think that's a universal thing, but you see why it's called the X box. It makes you think of a video game system. There's the X with the box. So that's one way to factor not so simple quadratics. Let's try it on these guys right here. So we start by doing the X. So can you tell me what goes here? Abby, can you tell me what goes here? 10. And down here? Yeah. So can you think of two numbers that multiplied equal 10 and add equal 11? Multiplied equal 10 and add equal 11. If it's not coming to us, we start writing down all the factor pairs, 1 and 10, 2 and 5. So do any of those factor pairs add up to 11? Yeah, I forgot about the 1 and 10. Yeah. So 1 and 10 do, yes. Let's move this out of the way. There's our factor pairs. And then we're going to draw our box here. So what goes in the box? Let's see if we can fill in the box. What goes in the top left? 5x squared. In the bottom right? Bottom right here. 2. What will help you to remember is that all I'm doing is rewriting this, right, into the box. But I've got to make 3 terms into 4. So how do I get the 4 terms? What happens with this middle guy?
Don't you just use these 2 numbers on the side of the box?
The 2 numbers on the side of the x are the way we're breaking up the middle terms. So the 1x can go here, and the 10x can go here, or vice versa. It doesn't matter. It's not going to matter. What will happen if you switch these up is you'll just get a different order for your factors. Like you'll have different factors side and top. Like they'll just swap. Okay. So what's the greatest common factor in the first row here, between 5x squared and x? I know it's Friday, guys. We got to be totally engaged on this one. This is a tricky lesson. But right here, what's the greatest common factor? In terms of numbers, it's 1. In terms of letters, it's the letter to the smallest power that you see here. So what's going to go here on the left edge? Just x. Just x. Which makes sense. I mean, our factors always kind of look like this. They're binomials. One of them has a letter attached and the other is a number, right? They all have the same form. So I have an x here, and then what's the number that's going to go here with the x? What's the greatest common factor between 10 and 2? 2. So x plus 2 is one of our factors. Let's erase our factor pairs up here. What about here? What's the greatest common factor here? Yeah, 5. And I'm going to attach an x. See how there's an x in each one? You'll always have a variable here and here. So in this position and this position, there's always a variable there. And then right here, the second column, what's the greatest common factor here? If you look at it and your brain's telling you there's nothing in common, that means it's a... Okay, so here it is. it's going to be 5x plus 1 and x plus 2. And what you really have to understand with this X box method is that you can multiply this out to get the original. There's a built-in check. The check's right here. Like, you don't even have to do the check. You're looking at it right here. There's the 5x squared that goes right there. 1x and 10x. Add them up. It gives you the middle term. 2 times 1 is 2. There it is. It's all right there. So you don't even really have to check it. You already did using this method. Okay. Next one. So over on this side of the room over here, let's make sure we got what goes up here. 14. And down here, 9. So can anybody think of two numbers that multiplied equal 14, add equal 9? 2 and 7 came pretty quick with you. It seems like to me, as long as it's not the number and 1, it comes pretty quickly, right? We forget the number and 1, so just be aware of that. Don't forget the number itself and 1. But yeah, 2 and 7 work. And then we go here, and top left, 7m squared. Bottom right, here and here, yeah, 2m. Sometimes what I'll do is, like, across the rows, I'll try to get the same numbers in there if they match up. But it doesn't matter. It's no difference. I should show you why it doesn't matter. I'll do that once. So this row is 7m. This row, the greatest common factor is 2. This row, it's 1. It's got to have a letter attached. M, yeah. And then this row is, yeah, we're thinking nothing, so it's 1, right? There's nothing in common. Well, it's 1. So this equals m plus 1, 7m plus 2. Let me just do an aside here. Don't write this down here, but I'm going to use this space down here. I have to show you this. If I had done the box, don't write this down. Just fold your arms, watch. And I'd written 7m squared, 2m, 7m, and 2. So I switched up the 2m and 7m. I've told you it doesn't matter. I have to show you. I think it'll help to. So across this row, the GCF would be just m. Across this row, it would be just 1. Now with the columns, it's 7m and 2, and you can see they've just switched positions is all. Okay, same factors, different positions. Because of the commutative property of multiplication that says 3 times 4 and 4 times 3 both equal 12, this is fine. Okay. So just be aware of that. Let's try the next one here. So I'm looking for factors of somebody from the middle here. You know, Adam, you tell me factors of what? 32. Yeah, and what goes down here? 13. Okay. And what if you're stuck and you can't think of, I don't know, what do we do? Well, we go back, we list 30, we start doing 1 times 30. Does 2 go into it? Yeah. 3, yes. 4, no. 5, yes. You just list all the factor pairs until you see one, like visually see one that adds up to 13. You see it up there? Yeah. Well, these ones have a difference of 13, so if there's a negative in it, you write it. But these are all positives. They got to add to equal 13. So we've got a 3 and a 10 here. And so we got box. So we've got 6x squared up here. We've got 5 down here. 3x here, 10x here. Have you seen this method done? Have you seen this one? Yeah. The other one, yeah. I'm going to get to that one. This one makes a nice connection between the multiplication and the factoring better than the other one. The other one's easy. It is, you're right. We'll get to that one too. That's next. So what's the GCF here? What we got here? What's the greatest common factor of the first row here? 2x. And then here it's just 1. And then here we've got 3x, and here we've got 5. So the factors are 3x plus 5 and 2x plus 1. Yeah. So there it is. Why don't you try the last one on here? So try the last one on here, and I'll put up the solution a little bit, but try it with the x in the box. See how that goes.